Right. So remember the operations we have access to. Okay? Um, we want, or we can just switch any row with another row. That's fine. We can multiply a row by any non-zero number, and then we can add multiples of rows to other rows to change them. Okay. So those are the things we have access to as far as being able to manipulate the system. And then our goal is to, with this, since you guys haven't seen one like this size yet before, we want that diagonal row of ones, but here we're only going to have one, or two rows. Okay? And then want that 0 down in the left corner, and then everything else can be just whatever value that it is. So that's our goal with our matrix, is to get the diagonal row of ones and the 0 in the left corner, and then just let those numbers follow along wherever they are. That's our row echelon form for that. But the first thing we need to do is turn that system into a matrix. Interesting. So what would the first row of our matrix be? How do we turn this equation into a row in our matrix? One, two, three, right on, Ruth. Oops. 1, 2, and then the augment bar, and 3. What about that one, Matt? The second row?
Well, with that one, aren't you trying to get first?
We will, yeah, but we got to write it down first.
First, we just do 2, 3, 4.
Yep. Just pulling those coefficients off there. Then we just want to kind of take stock that, compare what we have to where we want to be. So looking, this is what we want, and then what do we have here? And so we really should notice that that very first entry or very first element is already what we want it to be. It's already a 1, so we don't need to worry about it. Okay? So then as we move through, which generally is the easiest path, would be to just go down that left column. So we'd have to go to the 0 next, or we want to be 0, then you would go across that way. So we'd want to move down and look at the 2 next and say, well, how can we make that a 0? So again, the operations we have access to, we could switch rows, but switching that's not going to help us at all because that's not a 0. We can multiply by any non-zero number, but there's nothing I can multiply 2 by to get 0 besides 0. I'm not allowed to do that. So then we have access to, the last thing, which is to add some multiple of another row to this row to make this 0. So how do we do that? Okay. So if I had 2, I want this to be a -2 in order to add it down to get 0. So I want to take that row 1 times -2. I'm going to add it to row 2. So -2 times row 1 plus row 2. That's going to be my new row 2. So again, I like to write it next to the row that I'm messing with. I'm messing with row 2, so I like to write it next to row 2. But I'm not messing with row 1, even though I said I was multiplying by -2. We're just using that. We're not actually doing it. The 1, 2, and the 3's come over. Now I said I was going to do this. And -2 times row 1. So I need to figure out where I want to do that. Again, I like to generally just put it as close as possible to the thing I'm adding it to. I'm going to put that -2 times row 1 there. Making sure I grab these numbers, multiply them by -2. That'd be -2, -4, -6. I'm going to add -2 and 2, which should give me 0. Add 3 and -4, which give me -1. I'm going to add 4 and -6, which give me -2. So I got a new row 2 that now has a 0 as its first entry, which is what I wanted. So generally when you're trying to get zeros, it's going to be through some combination of adding some other row to it, because we can't get 0 by multiplying. So cool. So seeing where we are in our goal, that we now have that 0 set, so it tells us we should now look here. So what should we do here? Turn that into a 1. Multiply by -1. Yep. Let's multiply row 3 by row 2 by -1. -1 times row 2 will give us a new row 2. So I'm not changing row 1, so 1, 2, 3 comes across. So make sure you multiply each of those numbers by -1, so 0, +1, +2. So now we've changed the 3 things, or didn't, the thing we didn't have to mess with, but we've met our goal. We've got 1, 0, 1. So what we need to do at this point, the first thing we did was take the system, from a system to a matrix. Now I'm going to take the matrix and rewrite it back as equations, so we can actually solve for x and y now. So retranslate it back to equations. So Katie, what would the first equation be? Okay. Colby, what about the second equation? Okay. And of course, it should be pretty easy to see what we're going to do to find x, right? Plug that in. So x plus 2 times 2 equals 3. So x must be -1. And just write your answer as an ordered pair, so -1, 2. You could check real quick to see if that works, right? -1 plus 2 times 2, -1 plus 4 is 3, that checks. 2 times -1 is -2, plus 6, -2 plus 6 is 4, that checks. Checked in both. Right? So the front side of your worksheet is all, what I'm calling 2x2s, but they're really 2x3 matrices, but they're 2 equations with 2 variables. So they'll look pretty much like this and how you'll do them. They should be pretty short. We'll let you know that number 3 is kind of tricky, just FYI. Very doable, just a little tricky. Okay. Anything about that one you guys want to talk about? Grant, let me know if anything's blown over. I know you've been gone for a couple days, so. Let's go back to page 121. I think that's what it was. Yeah, 121. So we did a bigger problem again. So we did, we did page 120 on Friday. It's our first entry into this. Again, our row echelon form should end up looking like this. Diagonal row of 1s, 0s in the left corner, and everything else can just be whatever number it is. That's our goal, is to make our matrix look like that. We need to turn it into a matrix first. Victoria, what should our first row of our matrix be?
It should be 1 plus 1 plus 1 equals 6, or not equals, but 6 is on the
Yep, 1, 1, 1, 6. Yep, good. Wes, what about the second row? Grant, what about the third row? Always just go back and make sure you got all your signs and stuff like that. Because mess up any signs or whatever right now, it's all done there. So always just go back and reference this, right? Where are you at? Where do we need to be? And again, this is not set in stone, but usually the easiest path through these problems is going down that left side and across the bottom row and then back up. It's generally the easiest path to follow. So starting up in that top left corner and saying, well, sweet, already got a 1. So, don't need to worry about that. Yeah, you can subtract 2 rows. You can subtract, Maddie. I would tell you that you're probably better off adding a negative instead. People just are really bad at being consistent with subtraction. We like say, if I was trying to subtract, row 1 from row 2, we'd be like, okay, I'm gonna do 8 minus 1, and then do it, and then we start forgetting, we start adding from there. So I think you're better off adding a negative. It's kind of like when we did the long division stuff, and I said I really suggest you guys go through and change the signs and then add down. So, word of the wise, subtraction tends to be messy for people. I would suggest you do something different. What were you thinking though? What were you trying to do with subtraction?
I was going to subtract row 3 from row 2, because then the 7 minus 6 would make spot
Okay.
row 2 a 1.
All right, so you're trying to get this to be a 1?
Yeah.
So I guess the only thing that's bad about that is that we're still going to have to mess with this number over here also. And when we have to go to mess with that one, we might end up messing up that 1 that you created. So again, generally we want to follow this pattern here, running down the left side first. So don't worry about that number, but instead worry about this number. So what can we do about that 8 instead of worry about the 7? Okay. So Victoria's saying we can multiply row 3 by negative 8 and then add it to row 2. So that would turn that into negative 8, and negative 8 and 8 would turn into 0. Okay. So that's certainly okay to do, Victoria. I just might notice that there is something a little bit easier maybe, because when we multiply this row by negative 8, we're going to create some kind of large numbers. That'll become negative 48, that'll become negative 100 and something. Okay? Whereas if we use row 1, we won't get those big numbers. Does that make sense? So yeah, we do need to do some sort of multiplication by negative 8 in order to cancel that 8, but we have choices here. So I'm just saying that this should be a simpler choice since the numbers are smaller. So negative 8 times row 1 plus row 2 should give us a new row 2 where that element will be 0. But I'm not changing row 1. not changing row 3. And I would always suggest you bring those over first before you worry about the thing you're changing. That way you've created a space that's the only place you can put your new numbers is in that middle space. You don't accidentally put them in the wrong spot. But you need somewhere to do that work. We said we wanted to take, row 1 times -8. So, if you're just going to do that up here, so we're going to multiply all of row 1 by -8. -8, -8, -8, -48. And again, using your fingers or something to help you make sure you're matching the numbers up that you're supposed to be adding now, because we said we're going to take that new row 1, we're going to add to row 2. So you're grabbing that number and adding them. And this number and this number, this number and this number. Those are the numbers you should be adding. So you need to make sure you're skipping that middle set of numbers. So that gives you a 0, -1, 6, and then 16. So now we found a way to get that to be a 0. So our next step, so now in our new matrix, where should we be looking? Where should we be looking?
One in the third row.
Okay. The first one in the third row. What do we want that to be, Wes? 0. So we're putting our eyes here. We say we want that to be a 0. So how are we going to get this to be a 0?
Do we have to do anything to a row to add it to it? So I guess
No.
it's row 1 times
All right. Yep. Right. Row 1 times -1 plus row 3. But Wes asked if you have to do something to a row in order to add it to another row. You certainly do not have to do anything. If that had already been a -1, then you could just add them. But yeah, we did need to do something, but you don't have to do something. So we're not changing row 1. Not changing our new row 2. So again, we said we want to do row 1 times -1. So we need to make sure we do that somewhere. We want to add it to row 3. So I usually like to put it as close to row, whatever row I'm trying to add it to as possible. Just making sure that I'm grabbing all of these numbers here, multiplying by -1 first. So what would I put down here, Wes? I do -1 times row 1. Okay. And then when we go and do those additions, what would that give us? Hmm?
0, 5, 0.
Okay. So there's our new row 3. Oh, yeah, 10. Okay. There's our new row 3. And at that point, kind of again go back to what our map, right? What have we accomplished? So we've gotten this to be a 0 now. That's our first column matches what we want it to. Essentially, you kind of see that we're doing like the elimination method. Like we've just eliminated x's from these two equations. right? Think about the systems of equations we were solving prior to this, right? So we just eliminated those x values from those equations. Does that make sense?
No.
Maybe not like how we're doing it, but like that's what we're doing. Like these x's are gone. All right. So we have an x here, but then there's no x's. Like if we think back to the elimination method for systems of equations, right? It's about getting rid of variables. So we've gotten rid of these variables here. Okay. We just think about that's what we're up to. And we're doing it with the elimination method thinking. We're just using this new notation. Right? If I said, hey, if I just looked at these two equations here and I said, oh, how can I get rid of the x values? I can multiply that by -8 and then add them together, right? And that would eliminate the x's. Just purely go back to elimination method thinking. I could multiply by -8 and then add them, right? Which is what we said we would do here. Okay? We're just not looking at any of the variables. The variables are now, it's kind of like when we did synthetic division. Right? We took all the variables out. We just wrote the numbers across the top and did a bunch of multiplying and adding. Kind of the same thing. We're pulling all the letters out so we can just focus on the numbers. Okay? It looks all like mystical. It's how fast synthetic division was. So it's kind of the same thing. We're just pulling all the letters out, focusing on just the numbers. We're just doing elimination method. That's all it really is. Okay? So yeah, it looks all crazy since you missed 2 days of stuff, but that's all really it is. Okay? So our next spot here, right, we want that to be a 0. Okay? We got 3 choices. We can flip rows in to change them. There's nothing for me to put with a 0 here. I can multiply by any non-zero number, but the only number I can multiply 5 by to get 0 is 0, so I can't do that. So then we're left with, again, some sort of combination of rows to get 0. That's pretty much when you guys want zeros, that's pretty much the only way to get zeros, is to add rows together, some sort of combinations of rows to get zeros. So Matt, you're saying multiply row 2 by 5, and then add it to row 3, not subtract it. Maddie, why not use row 1 by like -5?
Because I like to work with positive numbers. So,
okay. So Maddie said let's multiply row 2 by 5 to then add it to this because that'll be -5. And I asked her why not just multiply this by -5 instead. She said she just wanted to deal with positive numbers. Any reason that we shouldn't use row 1 by -5 and then add it to here? Yeah. So we just did some work to get that to be a 0, and if we multiply this by -5 and add it down, we would turn that back into a -5. Yeah, which is not good. Be very protective of the work that you've done. Your next step should never undo your prior steps. So if I need this to stay a 0, I can only add it to stuff that's also a 0. You have to work with row 2. It's not a choice. So. So I'm not changing row 1. I'm not changing row 2. And we want to do that math, so just find a space for yourself. So Maddie, what's our new, so we're multiplying that by 5. What am I going to write down here?
Wouldn't it be 0, -5, 30, and then like the bar, and 80?
Yep. So then we're going to do that addition. So 0, 0, 30, and 90. So we've just turned that into a 0. On this equation, Grant doesn't have any x's or any y's, just has z value. And we want that z value to be, have that coefficient on the z to be a 1. Right now it's at 30. And usually the simplest way, at this point especially, to go from any number to 1 is to divide by that number, right? Or multiply by that fraction. At this point, if you're looking for getting a 1 up here, then you might want to do like some adding of something like that. Or, but at this point in the problem, the simplest way to get a 1 is just divide everything by 30, right? So I'm going to take row 3 and divide it by 30, or take 1/30th times row 3. Yeah, so however you feel like writing that, whichever makes more sense to you. That'll be my new row 3. Again, I'm not messing with row 1, I'm not messing with row 2, so I'm going to bring those over first. Where's it? 30th of 30 is 1, and a 30th of 90 is 3. So you see here, Grant, we have 0 x's, we have 0 y's, we have 1 z equals 3. We know what z is right now. We solve for z. So we've hit this. Oops. So we just have one more step, right? We want this to be a 1 instead of whatever. Thankfully, it's a -1, so that's easy to change. But see, Maddie, from like what you wanted to do, like the first or second step, like how that number has been messed with as we did some other stuff. So good to wait until now, because when I go to mess with it, I can't. 0 is going to be 0 no matter what. So I'm going to take row 2 times -1. Give me my new row 2. So just watch your signs. It should be 0, +1, -6, -16. That bottom row tells us that z is equal to 13. What's the equation that comes out of the second row? You guys see in there?
The
Yep, we have a -16, yep. Yep. And the top one should just be x plus y plus z equals 6. So just go from the bottom up, right? We know what z is, so y minus 6 times 3, so y minus 18 equals -16. So adding 18 over, y is 2. And then x plus 2 plus 3, which is z, equals 6. X plus 5 equals 6. X is 1. Just write your answer as an ordered triple. So x is 1, y is 2, z is 3. So 1, 2, 3. Remember what that represents, though. If you think about drawing that on a piece of paper, you have your flat piece of paper and you have your y-axis and you have your x-axis, and so you go right 1 for the x, and you go up 2 on your paper for the y, and then to do the z, you'd have to come out of the paper 3 spaces, so it'd be up in the air. Okay. You're finding a point in 3-dimensional space where 3 lines are crossing. It's kind of like looking up at the corner of a room to see that point where the 3 lines meet. So again, we can check our answer pretty quickly, make sure it's right. 1 plus 2 plus 3 is 6. 8 times 1 is 8. 2 times 7 is 14. That gives us 22. 14 times 3 is 42. So 22 plus 42 is 64. And 1 plus 12 is 13. Plus 3 is 16. Checks all three equations. You guys want to do another one together? You had enough. Got one more if you want. What you guys want to do? Matt's feeling adventurous. This one's kind of like the ticket problem that we did the other day when we did the word problems and the way that the equations are set up. So it is a 3-variable problem, right? There are 3 variables, but each equation only has 2 variables in it. It's still going to create, 3 column in the bar, and then still going to make a 3x4 matrix when you write it out. What's our first row going to be? Careful, Matt.
I'm sorry. 1, 1.
1, 1, then 0.
Okay.
So now, yeah, yep. Not 1, 1, 1, but 1, 1, 0, 1. 0 Z's. Okay, go for it.
2.
Redeemed. All right. What about this one, Ruth? 0, 1, 2, -2, yep. I always think it'd be a really good idea for you guys to keep, just hold this, like either you're writing it out or, you're looking back at this little map kind of thing. What's it supposed to look like when you're done? Okay. So you can keep track of what you've been able to do, and again, just that pattern. This is by no means magical. Okay? It's by no means the only way to do this, but generally this is the easiest path to follow through the problem. Okay. So letting us know where to start. In that top left corner, do we have a 1? And we do, so it's a little gimme there. So then we need to move down and say, well, what about that next one in the left? Right, we have this 2 here. So what could we use out of our 3 tools to make that a 0? I've done this problem 2 different ways from 2nd hour and 4th hour. They approached it completely different ways. It's kind of interesting to see it from my side of things. Being able to experience both those today. How should we make this a 0? Row 1 times -2 plus 2. Okay. So turn that into a -2 and add it to this. What else could we do to make that a 0? Okay, you're saying we can flip the rows? Okay. So we could just exchange these 2 rows to turn that into a 0, right? So here's our options. We want to take row 1 times -2 and add it to that, or do you want to just switch the rows? Okay, what's that? Switch them? Okay. So we switch them. So Colby, what does switching them do to us though? Like, does it create any problems or anything? Okay. All right. So we're not changing row 1, so let's bring that over. So just be really careful as you're switching rows that you make sure that things get in the right spots, right? That these numbers all should end up here. I don't want to accidentally. You are moving so many numbers and into different rows, it's really easy to let your eyes wander. Back and double check everything, that make sure all your signs and whatnot are the same. So granted, there we just basically we took the equations and we just flipped them, right? That when we're looking at a system of equations, that it doesn't matter what order the equations are written in. Right? Mathematically, we can just order the equations doesn't matter, so we're just reordering them. Take advantage that one had a 0. Okay, so goal met. We got a 0 here. So where are we looking now? Where should our eyes be? Two in the bottom row. Okay. So we should be looking here, right? And we should be trying to make that 2 0. You see how I was getting at, Colby? Asking the question I was asking you? The question I asked you earlier, like, did it create any problems? It didn't really create a problem, but we just kind of kicked the can down the road. Like, we had the 2 here, and we just kind of punted it, and now the 2's there, right? So we still have the 2, but it's just in a different spot. So we still have to address the 2. Yeah, but. Okay. So how are we going to turn this into a 0? Same question we had back here. How are we going to turn that into a 0? What do you think, Grant? Good. -2 times row 1 plus the 3rd row. That'll give us a new 3rd row. It's about being in these blank sheets, not grouping stuff today. Row 1 is not changing. Write it down. Row 2 is not changing. So write it down. Then go back and worry about row 3. So we said we want to take row 1 times -2. So -2, -2, 0, -2. And we want to add these. That gives me 0, -2, -1, -2. So there's my new row 3. But we made the first entry into a 0. Now we should be moving to the right. I'm looking at that 0 here. We're trying to get a 0 here. Okay, so you're going to want to take row 3 or row 2, multiply by 2, and add to row 3. So I'd like you guys to be trying those problems on the worksheet. Come to me with questions tomorrow. Really would suggest you not save it all for tomorrow. All right.